Spectra analysis is JASCO's analysis software package. While using Spectra analysis, measurements can be simultaneously obtained using Spectra measurement or any other measurement program. Once Spectra Manager is open, scroll down to Analysis and double-click on Spectra Analysis. To open a spectrum, choose File, Open, or select the Open icon in the menu toolbar. Prior to selecting the file, you can also preview the spectrum to be opened. If you have an abundance of data files and cannot remember the exact location of the file of interest, Spectra Manager provides a search file option. In Spectra Manager, go to View and select Search. If you know the name of the file, enter it in the Name text box. Or if you know part of the name of the file, enter it with an asterisk after the string. Then specify the folder you wish to search in and whether to include any subfolders in the search. You can also specify to search for a word or a phrase in the file by selecting the Other tab. Choosing the Date tab allows you to further narrow down the search function. After clicking Start Search, any located files will populate to the right. Clicking on the file once displays it in the window below, and clicking the Information tab displays the parameters used to obtain the spectrum as well as the data, user, and instrument. Double-clicking on the spectrum file opens it in Spectra Analysis. If you already know the folder that the file is located in and you wish to open it in Spectra Manager, select View, Folder, choose the folder you wish to open the file from, and double-click on the file to open it in Spectra Analysis. The Spectra Analysis window consists of two main components: a dockable workspace window located on the left side of the screen, and the view windows located on the right side of the screen. The workspace window shows the names of the open files in numbered views, and spectra are displayed in the view windows. Two or more windows may be opened simultaneously to display multiple spectra. Each window is referred to as a view. Additionally, multiple spectra can be overlaid in a single view. To do this, go to File, Overlay, and select your spectrum file. If two or more views are open, you can overlay spectra by dragging the selected file to another view using your mouse in the workspace window. To move an overlaid spectrum to a new view in the workspace window, click on the spectrum you wish to move and drag it so that a new view is created. You can also adjust how your spectra are set up by going to Window, Cascade, Tile horizontally, or Tile vertically. To close an entire view, go to File, Close, or select the red X in the top right-hand area of the spectrum window. If you would like to open files that are not in JWS format, click File, Import, and select your file name. To save a file, go to File, Save As. To save your spectrum in a format that is not a Spectra Manager 2 JWS file, go to File, Export. Then select the Save As type. You can save it as a JCamp, ASCII, CSV, or an XY ASCII. If you would like to save overlaid spectra in a view, go to File, Save Active View. There are numerous zoom options which allow you to better view regions of your spectra. In the View toolbar, you must first select which axis you want to edit. Clicking X modifies the X-axis scale setting, and selecting Y modifies the Y-axis. The Zoom Out icon reduces the spectrum horizontally or vertically depending on which axis you select. The Zoom In icon expands the spectrum horizontally or vertically. If you select the X-axis, these icons move the spectrum to the left or to the right. Selecting the Y-axis moves the spectrum up or down. Autoscale Y-axis resets the vertical axis to autoscale, while the full scale icon resets the scales of both axes in the current view. The Trace icon allows you to display coordinate data at an arbitrary point. Move the cursor over the wavelength you wish to view the data for and click on the spectrum. The red line corresponds to the coordinate data, and the values are displayed in the bottom right-hand corner of the screen. If you go to View, Monitor Bar, the values are also displayed in a larger format in the bottom left-hand corner of the screen. If there is more than one spectrum in a view, the Offset icon allows you to use the mouse to vertically offset the overlaid spectrum in the active view so that overlapping spectra can be more easily viewed and compared. The Data Processing toolbar is also customizable under the Other menu option. To add processing icons to the toolbar, select a button from the available toolbar buttons list and click Add. To remove a button from the toolbar, select the icon from the current toolbar buttons list and click Remove. Reset returns the toolbar to the settings prior to editing. Select an icon and then move up or down to change the order of the selected button in the current toolbar button list, which is then displayed in that order in the Data Processing toolbar. A separator can also be inserted in between certain options to organize by functionality. These toolbars can also be moved around to free up space in the spectrum window. You can also display or hide different toolbars by selecting the View drop-down list. You can also change the color, line style, line width, fonts, grid lines, ticks, and axes units under the View option. Selecting information brings up all the parameters specified in the measurement program. Here you can also view any processing function that has been performed on the spectrum, as well as when it was performed under audit information. When performing a data processing function, a new spectrum memory is automatically created once the processing parameters have been applied to the selected spectrum, so that the new memory can be saved separately from the original spectrum file. In the Processing drop-down list, go to Corrections, Baseline to correct the selected or active spectrum with a baseline. The two wavelengths can be selected by moving the boxes on either ends of the spectrum and connecting the points with either a straight line or a spline curve. Additional points can be added to the baseline by hovering the mouse pointer over the line at the point of interest, and once the syringe icon appears, clicking on the line. Delete point erases the last variable added point. Each variable point can be dragged along either the X or Y axis. The bottom figure displays the corrected spectrum. Reset restores the baseline to its original shape. The smoothing function reduces the apparent noise in the active spectrum to improve the signal-to-noise ratio. 4 smoothing methods are available. All are based on the moving average method, in which appropriate weights are assigned to the data point of interest and the surrounding points. The original spectrum is displayed in gray, while the smooth data is overlaid in red. The convolution width sets the number of data points to be packaged together on both sides of each data point. Values are immediately recalculated after changing the width. Noise elimination eliminates peaks due to noise. The peak is eliminated by connecting the designated horizontal axis ranges by a straight line. The wavelength range for eliminating a peak can be selected by dragging the two vertical bars in the top spectrum. Click Execute to display the corrected spectrum in the bottom display window. Select OK to create a new memory of the corrected spectrum. To cut the x-axis of your spectrum without changing the data interval, go to Processing, Corrections, Truncate Data. In the Method drop-down list, select No Correction, specify the data interval, and the wavelengths you wish to cut the spectrum to. You can also select the wavelength range by dragging the boxes in the upper spectrum. Select Apply and the corrected spectrum will be displayed in the bottom window. Select OK to create a new memory of the truncated spectrum. To perform an arithmetic operation between a spectra or between a spectrum and a constant, select the arithmetic option from the Operations drop-down list. If more than one spectrum is in the view, arithmetic operations can be performed between the selected or highlighted spectrum, and if only one other spectrum is in the view, that particular spectrum. If multiple spectra are in the view, the Select Spectrum dialog box will pop up and prompt you to choose the second spectrum. The operation to be performed is shown at the top of the dialog box. S1 and S2 represent the selected spectra and are defined immediately below the arithmetic operation. To switch S1 and S2 and reverse the order of the two spectra, select the Exchange button. Enter constants into the appropriate text boxes if necessary, and select the desired arithmetic operator from the drop-down list. The top spectrum display area shows the raw spectra. Click Apply to perform the specified arithmetic operation. The corrected spectrum is displayed in the bottom window. Select OK to create a new memory of the corrected spectrum. To determine the derivative spectrum of a sample spectrum, select Derivatives under Operations. First, second, third, and fourth order derivative calculations can be performed using one of two algorithms. First derivatives can also be used to find the inflection points in broad spectral peaks or thermal melt data. The derivative spectrum is shown in the bottom display field. Under the Peak Processing tab, Peak Find detects peaks and valleys in the spectrum. Peaks are chosen by selecting Top from the Peak drop-down list, valleys are chosen by selecting Bottom, and both detects both peaks and valleys. A threshold value is entered into the noise level text box to recognize the top or bottom of the peak. If the difference between the top and bottom of a peak does not meet or exceed this value, the peak will not be recognized. If the upper and lower limit is selected, the peaks are located between the values specified in the text boxes. The upper and lower limit ranges can also be selected by dragging the boxes on the top and bottom of the display screen along the horizontal axis. Select Apply to execute Peak Find with the specified parameters. The located peaks are designated by a red cursor in the spectrum display window, and the corresponding wavelength and y-axis values are displayed in the peak table to the left of the display window. These results can be copied as well. Additional peaks can be selected and added to the table by clicking on the desired peak wavelength and selecting Add. Any unwanted peaks can also be deleted. Click OK to display the calculated peak labels in the original spectrum view. The choice of label can be specified by going to View, Peak Indicators. Selecting None does not display the peak position. Bar denotes the peak position using a vertical bar. Bar data number denotes the peak position using a vertical bar and the peak number. Bar X displays the vertical bar and the x-axis value. Bar Y displays the vertical bar and the y-axis value. And bar XY displays the vertical bar to denote the peak position as well as the x and y axes values. And under Processing, Peak Processing, Peak height determines the peak height and peak height ratio for the selected peak or peaks. There are 4 calculation methods to select from to draw the baseline for the peak height calculation. A 2-point baseline uses 2 wavelengths to draw a baseline, while a 1-point base draws the baseline using a single wavelength. Depending on the baseline calculation method chosen, specify the wavelengths in the text boxes to draw the baseline, or drag the boxes in the spectrum display window to set the range. To calculate the peak height ratio, check the P2 box, click on the numerical values, and then specify those for the second peak. Select Apply to execute the peak height calculation. The calculated heights are shown in the results display field in the top right corner of the screen. Clicking OK also executes the peak height calculation, closes the dialog box, and attaches the results to the original Spectrum file. Peak area calculates the area of a single peak or the ratio of the areas of 2 different peaks. 3 calculation methods are available for drawing the baseline. A 2-point base, which determines the total area within the baseline range. No base, which assumes 0 absorbance or 100% transmittance as the baseline peak area. An independent base, which allows you to set the baseline and peak ranges separately. If a baseline is selected so that a peak and valley fall under the specified area, the area of the peak and valley can be added, subtracted, or ignored. If there is only a peak, all 3 methods provide the same result. If there is a single peak you wish to find the area for, select the 2-point base and ignore under baseline from the calculation method drop-down list. Select the baseline range of the peak using the vertical cursors or typing the value into the text box, and click Apply. The peak area results are displayed in the results display field to the right. To calculate the peak area ratio, select the 2 peaks you wish to ratio and perform the previous steps. Select OK to attach the results to the Spectrum file. The results can then be displayed by clicking the information icon for the spectrum. To calculate the full width at half maximum, select FWHM from the peak processing drop-down list. Set the full width at half maximum calculation range by dragging the vertical cursors on the spectrum, and the value will be calculated simultaneously. The range can also be directly entered into the text boxes on the top right of the screen. Click Apply to perform the calculation when entering the values in the text boxes. Click OK to attach the full width at half maximum results to the spectrum. To manually subtract a buffer spectrum from a sample spectrum, make sure the buffer spectrum is in the same view as the sample spectrum. Then go to Processing, Subtraction. If more than 2 spectra are in the active view, you will be prompted to select the spectrum to subtract from the highlighted spectrum. In the subtraction menu box, the sample and buffer spectra are shown in the top graph in the display area. The graph below it displays the subtracted spectrum. The factor text box is used to input a multiplication factor along with the step or interval by which the factor increases or decreases. Exchange exchanges the spectrum to be multiplied by the factor, while selecting Exchange Data exchanges the spectrum to be subtracted with the spectrum that you are subtracting from. For example, if you highlighted the buffer spectrum prior to clicking the subtraction icon, you can use the Exchange button to swap the buffer spectrum with the sample spectrum so that the buffer spectrum is subtracted from the sample spectrum and not the other way around. The order of operation is shown on the top left above the raw data, and the color corresponds to the spectra in graph 1. Select OK to apply the subtraction parameters and create a new memory. To convert the x-axis units of the spectrum, select Processing, X-Unit Conversion. Unlike horizontal axis units under the View menu, which only changes the x-axis units of the view, X-Unit Conversion creates a new memory with new x-axis units. To convert the y units, select Processing, Y-Unit Conversion. The Common Options drop-down list provides more data processing functions such as film thickness, which calculates the film thickness from the interference pattern that appears in the transmittance or reflectance spectrum of a film. Specify the calculation range by either dragging the vertical cursors on the spectrum or entering the values in the text boxes under Range and selecting Apply. Then enter the incident angle, the sample refractive index, and noise level in the calculation parameters area. The noise level is the y-axis range to be disregarded as noise when searching for peaks or valleys. Any peaks and valleys separated by less than this value are excluded in the calculation. Click Calculate to perform the film thickness calculation using the specified parameters. The results are displayed to the left of the spectrum window. Click OK to attach the film thickness results to the spectrum, which can later be displayed in the Information tab. Peak normalization normalizes the intensity of a specified peak position to an arbitrary intensity. This function can be used on multiple spectra overlaid in the same view. Specify the peak position by double-clicking the position text box and entering a value or dragging the vertical cursors on the spectrum. If more than one spectrum is selected, the peak wavelength can be set collectively by selecting the All Position checkbox. To correct for a baseline, double-click the baseline text box and select 1-point base. Then enter the corresponding baseline wavelength in the base text box, or drag the vertical cursor in the spectrum window. To use the same baseline wavelength, select the All Base checkbox. Auto Detect locates the wavelength of the spectrum with the maximum intensity and specifies the wavelength as the normalization position. Select Apply to normalize the data with the specified parameters and OK to create a new memory. Data Dump displays the data values of a spectrum and can copy them onto a clipboard to be exported or pasted elsewhere. Specify the range of data you wish to copy. Thinning designates the interval between data points to be used for display. Select Apply to execute the data dump process. Data accumulation obtains the average spectrum of spectra overlaid in the same view. This function cannot be performed on spectra that have different data modes, intervals, or measurement ranges. The kinetics calculation program calculates the enzymatic reaction rate from absorbance time course data. Enter the time range for calculating the rate in the start time and end time text boxes and clicking Apply. You can also specify this range by dragging the vertical cursors in the spectrum display window. The red line should be tangent to the curve at the time you wish to determine the reaction rate. The initial reaction rate can be determined by drawing the line tangent at t equals 0. A coefficient for the calculation can also be specified in the factor text box. The reaction rate and its associated variance and correlation are calculated. If a factor has been specified, the enzyme activity is calculated as well. The equation of the line is also shown in the top of the screen. Select OK to attach the kinetics results to the spectrum to be later viewed in the Information tab.